Okay, good afternoon, everybody. Good morning if you're on the West Coast. Good evening if you're tuning in from Europe or Asia. We're really happy to have you here. My name is David Banas, and I'm on the Gradient team here at Paperspace. I'm really excited to welcome you to another installment of the Paperspace webinar series. Today, we're presenting a special session that will cover the new Gradient container that we released last week in collaboration with our friends at Hugging Face. If you don't know about Hugging Face, they're the company behind some of the most exciting NLP libraries available today. We're really excited to have Morgan Funtavik here, who is a machine learning engineer with the Hugging Face team. We're also really excited to have Dylan Erb here. Dylan is the CEO and co-founder of Paperspace, and in a minute here, he'll jump on to introduce Gradient, some of the latest things that we're building, including the new Hugging Face Transformers container. Before we get to the session, we want to remind you that the chat function in this Zoom webinar is wide open for all your questions and comments. It's really fun when you chat in, tell us about your questions, your comments, anything like that. We'll get to the questions during the natural flow of the session as they come up, or during the end, we'll have a Q&A, and we'll try to accommodate everybody's questions, and we're really looking forward to hearing from you. If you use the Zoom chat function, make sure to select all panelists and attendees as your recipient so that everybody else who's joining us on the webinar is also able to hear what you have to say and participate in the conversation. At the end of the webinar and in about a day or two after, we'll provide materials from the presentation, including a recording and various links to the things that are referenced today by both Dylan and Morgan. So without further ado, I'll turn it over to Dylan. Thanks again, everybody, for joining us, and we hope you have a lot of fun.
Thank you, David. I'm going to share my screen here. Thanks, everyone, for joining. Looks like we have people from all over the world, which is really exciting. I'm currently calling in from New York, where Paperspace is headquartered. So let me share my screen here. Okay, so for everyone joining today, I'm going to just give a very quick overview of Gradient before jumping into the collaboration we've been doing with Hugging Face. It's certainly one of the more exciting partnerships we've had. We are big fans of Hugging Face here at Paperspace. So to begin here, if anyone wants to kind of follow along, the website gradient.paperspace.com will give you some overview information about Gradient, the product. And I will just jump in. If anyone wants to actually follow the notebook as well, I'll show you how to do that. So let me just begin here. So today I'm going to give a quick intro. We'll talk about sort of the Hugging Face notebook. Morgan's going to give us a demo of the Transformer library and a few interesting pieces around that. And then we'll open up to a QA or Q&A. So for those of you that are not familiar with Gradient, it is a set of tools, web-based tools that help developers more quickly build, train, and deploy deep learning models. It's a suite of tools that includes a Python library, a GitHub integration, and a bunch of different tools for interacting with machine learning models. So if you create an account, which is very easy to do, and if you don't have one already, feel free to go to paperspace.com and create one, or gradient.paperspace.com. You can sign in with GitHub or Google, and you'll be presented here with sort of the three high-level areas. So we have a notebook runner, an experiment tracker, and Python SDK, as well as tools for actually turning your machine learning model into a production or development endpoint. Today, we're going to focus on the notebook side of things. So, at a high level, just for those of you that aren't familiar, machine learning can be very complicated and hard to integrate with. But generally, the flow looks very similar, which is that you have kind of data coming in. You want to build or train a machine learning model, evaluate that, and ultimately deploy it. And so, our approach to this is very much what we call an agile approach. So things like versioning, adding identifiers to all entities in the system, and really making it a very friendly developer tool. And happy to go into more of that during the QA. But we've identified a few problems with the space today that we've been working on making easier. We've identified these as, the lack of tooling and best practices, hurdles to productionize, and also just the reality that you have to use hardware all over the cloud. And so being able to support everything from CPUs to GPUs to, new hardware that's coming out. So the thing that's most exciting in my mind about Hugging Face is that, it really gives you, in really just a few lines of code, access to cutting edge, state of the art NLP tools. So we worked with Hugging Face. We've been collaborating for a while now and excited to, last week, we actually launched a Transformer notebook with all of the dependencies built in. So for those of you that aren't familiar, the Gradient notebook architecture is such that it is running in a container. And so what that means is if you were to go to the ML showcase and click launch project and create an account, you can actually run this on a free GPU or CPU. And you can, basically all the dependencies are installed and it's ready to go. So if you do want to follow along here, I'd recommend going to mlshowcase.paperspace.com and clicking launch project on the Hugging Face notebook. And so, when you go in, I'll kind of walk through the interface here. Under Gradient, there's notebooks. You can create a new notebook. We actually provide a number of pre-baked containers, and the newest one here is the Hugging Face Transformers kind of overview and examples. And again, this gives you access to, within a few clicks, you will be able to actually test out all of the Hugging Face libraries and, tap into really powerful models that are trained, thousands and thousands of hours on large corpuses of data, and actually being able to apply that to your own architecture. So we're going to jump right into the demo here. What I'll hand over to Morgan. So for those of you that aren't familiar, Morgan is an ML engineer with Hugging Face. He's going to provide a walkthrough of the notebooks that we've put together. And again, feel free to ask any questions, bubble up any thoughts if anything's not clear. We want this to be very interactive. So with that, I will hand this over to Morgan, and then we will open up the demo here. So Morgan, I'm going to hand this over to you.
Perfect. Yeah, hi everybody. I'm very happy to be there. Thanks for Paperspace team to having such great collaboration. So I'm going to open the presentation we made so far. Okay, I need to share my screen. There it is. Okay, so perfect. So I will go through the agenda for today, but first I would like to introduce myself. So as Paperspace people said, I'm a machine learning engineer at Hugging Face. I joined the company late last year in December. Before that, I worked for Microsoft Research in Cambridge. And then I moved to Nevolabs Europe as a research engineer, working on various topics from reinforcement learning to computer vision and more recently NLP. And as many of you, I'm sure, I started working with the Hugging Face, the Transformer library, and then I decided to move there. So it's really exciting to be among you. And today I will speak more detail about the Transformer library. So basically, you can think about the Transformer library to be a single place to allow everything that is possible right now with NLP. So we provide state-of-the-art models from BERT, Roberta, GPT-2, Albert, Electra, T5, and plenty of others. Along with the model, we provide all the tokenization methods that I might have time to speak a little bit at the end of this talk. And also what we really think is important to us is to provide this as an open way for the community to build stuff upon. So basically you can sign in on the platform, you can upload some models, you can download some models that were trained by people around the world. And this is really what we are happy with. So first I will speak about Transformer, how to use the library and what is interesting for and stuff like this. And then I will move to something maybe higher level through the use of pipelines. So pipelines provide a mechanism to use the state-of-the-art model through a single line of code. And we provide many different downstream tasks for this. So ranging from feature extraction to sentence classification, token classification, question answering, and more recently we released summarization and translation that we try to give you some demo later. And yeah, as I said, I will try to speak a little bit about tokenizer. So basically, many of you may know about it, but for those that are not aware, tokenizer maps from a huge vocabulary that we use as our day-to-day languages to a subset of this with that can share some specific statistical properties to reconstruct as widely as possible the initial big vocabulary. So we provide a very fast implementation that is named tokenizer, so that everybody can share very easily. And we provide all the state-of-the-art tokenizer through this library. Okay, so I will jump to the notebook so that you can see what we've done so far with the paper space. So maybe I should do this. And I should share where it is. This one, perfect. Okay. So if you go to the paper space notebooks, you will see 3 of them. So one is about transformer. I mean, all the stuff generally available through transformer and what you can do. Then there is a strong focus on pipelines and what you can do with, how you should use them, how you can download some specific model and stuff like this. And the latest one is little bit more technical, is about how you train your very own tokenizer for very specific vocabularies. Okay, so let's jump into the transformer introduction. So basically, the transformer is kind of architecture that was released by Google through BERT, and it has been a very huge revolution, I would say, in the NLP community, because we were using some recurrent neural network style model. So basically, you have a sequence of words, and then you iterate over that sequence word by words with a kind of shared state in the middle that you keep updating along the sequence. And it was like very, very bad for all the kind of hardware we have so far. So I'm thinking about TPU and GPUs right now, because it's a kind of iterative process and you cannot just feed your data and stuff like this. You have to iterate, you have for loops and stuff like this. So it was very interesting, the BERT release, to have a new kind of idea to think about this. And basically you just provide a bunch of sequence, a bunch of words, sorry, and then everything will be looked at the same time in a single operation. So this is basically what transformer is at its core. So here is the picture you can see about the overall architecture. I will not go over the detail because there is some very detailed blogs that speak about it. I'm thinking about the annotated transformer. You can have a look and you will understand everything you need about transformer. Okay, so basically the transformer library is just like as easy as any other Python package to install. So just like pip install transformer, and then you will get access to all those state-of-the-art models, tokenizer, and stuff like this that we provide so far. So as you can see here, we provide a bunch of auto stuff that we call. So auto model and auto tokenizer. Basically, it's just that the library will try to guess as much as possible what it should allocate for the models and what it should allocate for the tokenizer, so that you don't have to worry about, oh, should I use this kind of tokenizer, this kind of other tokenizer? I don't know what is the size of this embedding and stuff like this. All of this is managed by the library.
Morgan, a quick question. We have one in the chat here that
Sure.
maybe is worth jumping into. The question comes from Jax Tan. It says, he's asking, under what conditions should we retrain the tokenizer? And is there a measure, if the pre-trained tokenizers that Hugging Face provides actually work well?
Yeah. So basically, depending on, okay, models comes with their own tokenizer and their own vocabulary, and it's very hard to, to change this without retraining from scratch. So you will have some cases where the tokenizer will provide a mechanism to handle out of vocabulary, but imagine you are using, I don't know, some a very general data set like Squad, trained on Wikipedia articles, and then you move to something more more related to nowadays news, so about coronavirus, then you may have some kind of molecules names or stuff like this that might generate some out of vocabulary and that will reduce the overall performance of your model. So in this case, you may have to retrain your tokenizer to focus more on your vocabulary you are targeting. But training the tokenizer very often means retraining the overall model because the embeddings will not be aligned otherwise.
Morgan, another follow-up here. There's a question about kind of hardware support. So, does it matter if you're, doing this on a CPU, GPU, or, TPUs on the Google Cloud?
Yeah, so through the library, we provide out-of-the-box CPU and GPU. So you can do inference, you can do training on CPU and GPU through PyTorch and TensorFlow. And quite recently, my colleagues, Lysander, just set up some training scripts for running training on TPU. So you can leverage some TPU there. It has been included quite recently, and well, the performance are very impressive so far.
Awesome. And then you had mentioned kind of before this call some performance implications of tokenizing. I know that Hugging Face had released a kind of more performant version. Can you say any comments about just the performance and how you guys think about it?
Yeah. So as you may know, Python is not the best place if you need to run some heavily parallelized task, and tokenizing stuff might be seen as something that can be very, very parallelized. So all our tokenizer were implemented through Python. There is kind of exception for sentence pieces tokenizer that were provided as a native library, but all the other one were running on Python, so very bad at parallelization. So we took the opportunity there to rewrite all the word piece and byte level tokenizer through a native library called tokenizer written in Rust, which is kind of C++, at least native for the platform library with a Python binding that allow people to leverage the Python language and all the stuff that comes with the ecosystem and stuff like this, and also have access to all the parallelism and performance improvement from a native library.
Awesome. And we have another question just so that everyone can kind of hear your response. You'd mentioned TensorFlow, PyTorch. Is Keras supported? Are there any limitations into where you can use Hugging Face, or any benefits of picking any particular framework?
Yeah, but most of our models should be compatible with the Keras interface. If it's not the case, you should report in the issue because this is something we like to push. So definitely Keras is something we support. And also we are kind of integrating some JAX-based library. So this is currently as a pull request, and this is something that I'm working on, so I can speak a little bit about it. And basically, we will provide an interface through the Flax frameworks very soon for all the BERT model.
Awesome. And then just one more here, question about how much training data is required for effective tokenizer retraining. You might cover this a bit, so we can keep going, but just a question on sort of the data that you'll need to be effective in using this.
Yeah, I'm not sure about like the numbers, so I don't want to say something wrong, but basically you need a lot of data. I think you need something. There was some paper mentioning that you need about like 1 million tokens or stuff like this, but definitely you need a lot of tokens and a lot of text.
Awesome. Yeah, let's keep going here. I know everyone is eager to get into the demo.
Yeah, sure. So as I told you there, the library will try to do its best to allocate all the required pieces to get you started using BERT and all the other model based on this architecture. So for simplicity there, we will go through the initial BERT model And basically here you can see that we provide some kind of identifier for the model that we will use. So basically this is the name of the model. This is kind of the size of the model. So we have base, we have large, we have some distilled versions that we do at Hugging Face. And then here you have, if the model is a train on a case input or uncase input. So providing this to the library will allocate the model, and then you will have access to all the weights ready to go, ready to forward, and getting some output from there. One very important part of being able to use those models is getting the right representation for the raw input text. So basically, this is where the tokenizer come into place. And through the transformer library, we provide some very high-level API to tokenize, transform, and do all the operation required to successfully do a forward pass over that model. So just to give you some idea there, so tokenized will take an input sequence that you can see here, and it will generate all the tokens in a textual way. But this is just for debugging purpose, or maybe at least not forward purpose. It's more like a sanity check, I would say. To be able to use those models, you will need to convert all those individual tokens to an integer representation, a number. And this is what convert to token ID is doing. So providing this list of tokens that you can see here, it will just generate the number representation for each of these words. Then we are getting closer to being able to forward, but okay, BERT model has also introduced or use extensively what we call spatial tokens. So spatial tokens are kind of tokens that should not be split by the tokenizer, and that should be put at very specific places so that the model can know about some underlying property of your text. So basically for BERT, this is what we call, and maybe you heard about it, this is what we call the CLS and the SEP token. And basically you will wrap your tokens that you can see there through those CLS and SEP tokens that you can see over there. So 101 and 102 are CLS and SEP. And you can see that it just copy paste of the initial tokens there. And this is achieved by build input with spatial tokens there. So basically you have 3 steps. If you think, I mean, if you want all the details, so you take a raw string, then you get out all the tokens in a textual way. Then you convert those text token to an ID that is mapped to the vocabulary the tokenizer was trained on. And then you add some specific tokens at the beginning and at some very special places so that the model know exactly what it should focus on. And then, okay, we convert to PyTorch there, and okay, let's go. So we have an output, as you can see. So we have only one sample, so only one sentence. This sentence is composed of 7 tokens. And for each of the tokens, you have a representation, a vector, that is 768. And then you can also use what we call the CLS representation of the token, of the sentence, sorry. So basically you will pull out all the tokens you can see on the second axis there to get a condensed representation we can see as a summarization of the overall sentence. So this is the, I would say, the hard way to use the transformer and the tokenization. So of course, we provide a higher level API for doing this, and everything is done through the encode plus methods and batch encode plus methods. So basically encode plus methods, and this is the same for batch encode plus, so I will just speak about encode plus there. We'll take an input as we did before over there, and it will do all the steps that we described before for you. So basically all this piece of code is just summed up here with only one line. And then you are able to just expand your dictionary with all the keys, and that's it. You have the model that will be, I mean, all your data will go through the models, and you will get exactly the same output as you can see there. So difference with the previous code, so this one is null. So there is absolutely no difference. So as you can see there, with only one line of code, you are able to use a BERT model without knowing anything about it. You just need to know that you need to tokenize and then forward, and that's it. Okay, so one other interesting component of BERT, and this is something that is integrated into the library, is the fact that BERT is able to handle pairs of input. You can think about pairs by being some question and context piece of text that should interact together somehow. And for doing this, again, we will use the encode plus methods, and this will just encode this sentence and also this sentence independently, but it will generate a special tensor that will be the segment tokens that will say to the model, oh, okay, this is the first part of the input and this is the second part of the input. And then the model will be able to correlate all of those tokens from the different parts to make some correlation between them, and being able, for example, to answer a question with respect to a context that was provided. So as you can see there, for example, here is a simple input, as we said, so the CLS and the tokens, then the integer representation, and then the segment type. As you can see, there is only 1 0, so only one kind of input that was provided. And then if you go to a pair input, then there you will see the CLS, the segment A, a separator, and then the second part of the segment. And you can see that this is only one tensor in the end, but with different segment type. So 0, 0, 0 is for the part A, and 1, 1, 1, 1 is for the part B. And then you can feed this to the model, and it will generate the correct representation for it. Okay, so batch encode plus is basically exactly the same as encode plus. It's just it supports multiple centers at the same time and distribute the work over all the threads you have on your CPU. So this is very convenient, and it can provide a very huge speed up for some very high demanding cases. Earlier, I spoke about like the interoperability of the model. So basically, we provide PyTorch and TensorFlow models out of the box. So you can jump in between those frameworks very easily. As you can see, there is just a prefix to add to use the TensorFlow model, so the TF, in front of the model you want to use. And then everything will be run through that specific framework. Then we try to design everything to be very compatible. So you don't have to care about like, oh, I'm using TensorFlow, I'm using PyTorch. All the methods that come from the tokenizer will give you the correct output ready to be fed to the model with respect to the platform underlying. So basically, just the only thing you need to know is if you need to return the TensorFlow tensor or PyTorch tensor, and it will do everything you need for you. And then you can see there that there is absolutely no difference in calling both. So it's very easy and very straightforward. Okay. Last year, I will speak a little bit about this, but I will go kind of fast on this. Last year, my colleague Victor released a distilled version of BERT. So basically, you can think about distillation just to be a kind of teacher and student setup where you have your huge BERT model that will be the teacher, and the distilled version that will be the student. And the student, by some combination of losses and training stuff, will be able to learn from the teacher through a more constrained and reduced representation. So this is really cool, because if you think about BERT, it's like 340 million parameters, and through distilled version, you are able to reduce this by 30 or 40%. So the inference time will be reduced, the downloading time will be reduced, you can share it more easily and stuff like this. So this is something very interesting. And of course, as this is something we did, we really wanted to emphasize on this. So basically we provide distilled version for BERT and Roberta through the library as easy as all the other models. So just you can give it a try, and you will see that the performance will not be far from the original one. And finally, speaking about the Transformer library, I said in the intro that we think about Transformer to be kind of a universal repo for the NLP community to share and demonstrate what we can do with NLP. So in that purpose, we built some kind of hub, if you think about it, to share and download models that were trained by the community. So you can just sign up on the platform and then say, oh, okay, I've trained a very cool model on some, I don't know, language that is currently not present in the library and I would like to share with the other. So fine, just go to our CLI. There is no example there, but there is some documentation into the library they can find. And then through the CLI, we'll be able to say, oh, okay, I want to upload my model, and the CLI will take care of uploading all the parameters, the configuration files for you, and then following the same schema as we did so far. So just providing an identifier for the model, you will be able to download community trained model out of the box in the library. Perfect. So this is the end of the first notebook that we released about Transformer. I don't know if you have any questions so far about it.
We have a couple, so maybe I'll just take one here
Yeah, sure.
while we're on Transformers. We have one. The question is from Arnav, how is the condensed pooled representation created, and can this representation be used as a sentence embedding?
Yeah, so this is an interesting question, thanks. Basically, if you imagine you have a sequence of T tokens, then you can extract two different kind of representation. You can extract the overall sequence representation with one vector for each tokens in the sentence, but you can also extract what we call here the pooled representation. Let me just find it again. Where it was. Sorry. Yeah, the pool representation there. So basically, if you remember, we had some special tokens that are included into the initial sequence. You have the CLS for birth and the SEP token in the end. And what we do for getting out the pool version is that we only focus on the CLS token. So basically, we discard everything about the sequence and just take the representation of the CLS, and we add an additional layer, just a feed-forward layer, to project again this representation to the same kind of tensor in the end.
Awesome. There's another question on text classification, but I think maybe if we go to the next notebook or the rest of the demo, maybe we'll cover that.
Okay, perfect. So I'm switching to the pipeline. So as I said earlier, early this year, we introduced the pipelines. So basically, pipeline can be seen as an embedding of the tokenizer and the model for you. So you just have to do a single call, and everything will be done from the library for you. So we provide out of the box name entity recognitions. What else? Question answering, feature extractions. And I'm missing one. Yeah, sentiment analysis, sorry. So all of those are ready to be used. And quite recently, we released also two other. There is the summarization one that was made possible by my colleague Sam through the use of the model BART from Facebook, and also the model for translation that is using the huge model from Google, T5. And this is a work from Patrick, also on the Hugging Face team. And all of those are very easy to use, and basically you just need only one line to be able to get started with those downstream tasks. So, oh, and sorry, I forgot there is the mask filling that was made available by Julien. So basically it's just like a mask language modeling. So imagine you have an input and you want the model to complete some missing space in the middle of the sequence, then the model will generate the missing part. And all you have to do for doing this is just like call the pipeline from Transformer there, as you can see there, by just providing the task name. And there is multiple way you can, of course, tune this. So basically, you can just say, oh, okay, I want to use, for example, a question answering pipeline, but I want to use my very specific model. So by doing this, you can leverage all the community train or also your very own model and your very own data, and just with a single line of codes, be able to use them. So I would like to give you some kind of idea of how it works. So I was saying pipelines, you just provide the name of the task, and then you call it with your input, and then it will give you a very simple output in this way. So for example, such a nice weather outside. For the sentiment analysis pipeline, will give you a positive label with a very high confidence score. You can do nearly exactly the same for the name entity recognition. So NER there, again, you provide your input. We support there also batch input. So it's just for making it easy for people to understand what is going on, that we don't put any batch input, but it's supported. And then it will generate for every token the representation and the name entity recognition so far. Okay, I mentioned so token classification, sequence classification, then the question answering one. If you remember, I spoke about the pair encoding in the BERT model. So basically, this is exactly what is going on there. You have the context that you can see on the left. So Hugging Face is a French company based in New York, and you provide alongside a question, where is based Hugging Face? All those sentences will be combined all together in a shared representation in the common tensors with the segments that we see just before. And you go over some extractions part that is done in the pipeline, and then it gives you over the score for the answer. It gives you the position where you can extract the answer, and of course the answer. You can, for this pipeline, there is something interesting, is that you can tune, for example, if you want to retrieve, I don't know, the top 3 answers, then you can just say, oh, top k equal 3, and it will generate the 3 most relevant answer. So mask filling, I was saying. So mask filling is basically just trying to put some word instead of having a mask. So there you have an input, and then you want the model to fill the input with some generated token. So you will have a mask at the end, and it will generate, for example, Hugging Face, a French company based in Paris, based in Lyon, based in Geneva, Brussels, in France. And you can generate some very small piece of text this way.
Morgan, actually a question here, just because I think it's an interesting one.
Yep.
What is the process for doing custom named entity recognition?
Okay, yeah. So basically, through the library, we provide some examples. So let me show you on the notebooks. So there, we are inside the transformer repository. So basically, it's just transformer / examples that you can see on GitHub. And if you go there, you have multiple examples for different tasks. So we have an example for NER, we have an example for glue, we have example for squad and stuff like this. So if you go to the NER, you will be able to train your model on PyTorch and stuff like this. You have TensorFlow and PyTorch, yeah, of course. And you will be able to train on your very own data, your labels, and with the model you want. And basically you can tune nearly everything. And it's definitely supporting, I think this one is supporting TPU also. So, okay, it's quite convenient to train your very own model.
Awesome. And you'd mentioned the pipeline accepting batch inputs. For the Q&A task, we have a question about just, does it accept a CSV or text file with multiple contexts and questions, just in terms of interacting with this with the pipeline library?
Yeah. So here I'm just showcasing the Python API. But as I said before, we are also providing a command line interface. And basically, through this command line interface, you can interact with the pipelines, and it supports CSV input, JSON input, and also some standard inputs from the console directly. So you can, without any line of Python code, you can use all those libraries directly through the command line arguments.
Awesome, thank you.
Cool. So, okay, let's continue. So projection is just like, if, for example, if you are willing to just get some representation for BERT, I don't know, for example, if you are building a retriever, if you are building some downstream task or anything else, you can just extract the last layer representation for the input. So basically, this is exactly what it does there. You provide an input there. So Hugging Face is a French company based in Paris, and then it will return the tensors with all the tokens representations. So for example, if you take BERT, it will be like the number of tokens in the input and 768. You can see there. Okay, so this is what we had so far with the pipelines. I just would like to show you some of the newcomers that we have in the library. So basically, this is a translation pipeline and the summarization. It's currently not in the notebook because it was introduced it's quite recently. It's only available on the master, but I will just try to show you how it works. So basically, I was saying that we had summarization and translation available. Translation is not, you take any language and you can map to any other language. We provide English to French, English to German, and one another that I can't remember there, but we have 3 of them. And for summarization, we are leveraging a BART model so that you can make some very cool summarization out of very long text. So this is kind of the output you have for the translator. So my name is Morgan is mapped to Je m'appelle Morgan in French. And you can provide some other stuff. As I said, you just need to jump in here with your very own input and it will generate the translation. And this is kind of the same for the summarizer. So providing an English input only for the moment. You can, so this is a Wikipedia article about Albert Einstein, and you can generate some very short representation of the same content. So as you can see, it's quite long input and it generates just something very relevant there. Okay.
Awesome. Thank you, Morgan. This is great. Really awesome demo. I think, you know, the Hugging Face team has been pushing out a lot of great work here. And I think the most interesting piece is that, you know, it's, as you just showed, very easy for any developer to very quickly just tap into a lot of, you know, just very powerful models here. So there is a question. I'll just kind of go through a few of these. There are a handful that came in. You see the first one here. You know, custom pipelines. You mentioned some of these new ones. You know, translate English to French. Are there examples on building out custom pipelines? Where would we find that in the GitHub repo?
Yeah. So for the pipelines, we provide, I mean, only the subset of all the downstream tasks you can think of. So if you go to the repo, I will just do this in real time. So basically, if you go to the repo, blah, blah, blah. Okay, we are on Transformer.
Actually, can you zoom in just a little bit, just for the people that have smaller screens?
Sure. Is that okay this way?
Yep.
Perfect. So we are on the repo there. Don't forget to add a little star if not the case. And you can go on the source center transformer and you have a file called pipeline. It's just there. Okay. And this is basically everything that I just spoke about. So we have the arguments for the CLI. We have the data formats. So I say we support CSV, we support JSON, we support pipe inputs, and blah, blah, blah. And in the end, you will find all, sorry, it's quite dense over there. Okay, over there you will have all the supported tasks so far. So basically we have feature extractions. And if you remember, you are able to just say, oh, I want to use the pipeline with this task. And basically we have for all the models, a default model that works well in the most general situations. So here the default is the model that should be allocated and with the tokenizer. And you can see that you have like feature extractions, terminal analysis, NER, question sharing, field mask, summarization, and some other translation. You cannot really have some other pipeline outside, I mean, outside of the set that is described there. But if you have some use cases that might be interesting for the community and you would like to work on, we are really happy to work with the community to provide such. So feel free to open a pull request and we'll see if it fits our requirement, if we can allocate some time to work with you, and also if it makes sense more globally for the community to include in the library.
Awesome. Morgan, there's a question from earlier that I thought was pretty interesting, and it kind of gets into the use cases for these libraries. So the question was, I'll just read it out. If my data is a file encoded in a string, then how does tokenizer encode plus behave? This could be for a sequential task like music generation, not for NLP. And I think more broadly, how have people extended this? Are there applications outside of direct NLP, or interesting kind of additions there?
Yeah. Okay. So the transformer library is really dedicated to NLP, but so it will be really easy to use with NLP stuff, but you can think about those models to be more generally available to other tasks and other domain. I'm thinking about BERT and stuff like this. So if you think back to LSTM or at least AREN and stuff, you were able to use it on NLP, but also on sound, on signal processing, stuff like this. So this is basically the same for all this kind of new architecture, but you will have to handle all the pre-processing on your side. So for example, I don't know, for music, you cannot use tokenizer. You will have to do some, I don't know, some spectrum analysis to extract some feature from there. And then you will have to train your model to react to this specific vocabulary, let's say. And also thinking a little bit, for example, architecture like WaveNet, you will have to handle some kind of masking for not generating in the future, or at least not taking input from the future and stuff like this. So it might be possible. It will require some work. It will not be as straightforward as it is for NLP task, but it should be possible to leverage raw model out of the box to train on different domain.
Awesome. I don't know, Morgan, if you're looking in the chat here, there are a handful just kind of coming in. A few questions. Just high level. I know we talked a little bit about it, but is there a way to fine tune a pre-trained language model, example BERT, on a new unlabeled corpus? And it sounds like it looks like the response there is there's a fine tuning example within the GitHub repo as well.
Yeah, exactly. So basically, this is the same as for in ER. So basically, if you go to the example folder, you will have something called run language modeling. And basically, this is doing exactly what you described there. So you can, I'm just jumping into the arguments so that you can have a better understanding of what I'm saying there. So basically, you just provide a model name or a path. So path is more if you pre-train your own model and you want to fine-tune on some of the task or stuff like this. And model name is more if you want to use one of the model we provide out of the box. And you will describe what you want to do. So for example, mask language modeling with the probability of this to happen, and then the configuration, the tokenizer, you provide the number of epochs you want to fine tune, and then you will be training on your very own data.
Awesome. A question actually. So as people are diving deeper into Hugging Face and retraining or refitting, there's a question around BART as a model is pretty large, hard to fit in memory. On Gradient, we offer free GPU and CPU instances, but when you're thinking about sort of the instance requirements, what's sort of your thinking on it for kind of the size of a task?
Yeah, so this is kind of related to what I was saying when we spoke about distillation. So we had some kind of very impressive curves that can show there. So basically you have the time on the x-axis and then you have the size of the model over the y-axis, and you can see that it's just increasing. So for example, we have the T5 model that was released by Google, and I think the largest one was 42 gigabytes. So it's just impossible to make it available on single GPU. And for this, we are trying to provide some I would say, reduced version. So basically, we do not take the large version. We'll take some kind of a reduced version that provides maybe some specific task or specific language or stuff like this so that to be able to allocate on the GPU. For T5, for example, if you think about it, there I'm using, so the translator is run over T5 and summarizer is run over BAT, and I'm just using the GPU available on the Paperspace platform. So it's a 24 gigabytes P5000 GPU from NVIDIA. And I think I have plenty of space available to be able to just run those models. I don't know if you can see. Okay, there is 8 gigabytes running for the moment. So those model fits into the memory of the GPU. For the bigger one, I mean the bigger versions of those models, you may have to rely on some other tricks, some other distribution methods. Microsoft released some distribution methods to run in parallel some part of the model on different hardware and machines remotely. You have something that is called TensorFlow Mesh that is able to do the same for TensorFlow. So we don't support this out of the box inside of the library. You may have to do some kind of engineering for this, but this is possible.
Awesome. I know we're not going to be able to get to everyone's questions here, so I apologize, but I want to be sensitive with time. We have one other one that I also think is pretty interesting that I just want to bring up. Is there any support for pre-trained or any support pre-trained models or examples for custom and relationship extraction?
I'm not sure. I don't think so for the moment, but yeah, I think the best here is to go to the website. So we have a Hugging Face website, and if you go on models over there, then you will have all the list of the supported models so far, either from the community or the official ones, if I can say so, the one that we release as Hugging Face. You will be able to filter by language, by task you want to achieve. And this is definitely the place if you want to have a look at what is available through the library.
Awesome. And so, as we're kind of winding down here, first of all, thank you so much for graciously walking us through this. I think this is extremely interesting, and I think a lot of folks can build really amazing things on top of it. So as a final question, if I think everyone should go and start Hugging Face on GitHub, but what are the other resources if people want to dive deeper, anything you want to point them to from the Hugging Face?
Yeah, so we have so GitHub is the main place, I would say. This is where we tend to have everything. We also have the documentation if you want to get started. Basically, it's over there. So we have plenty of tips to get started, the list of all the models we have so far with some kind of detailed description of what is under the hood. You will have some information about how to tune, how to train, how to run inference, how to run pipelines and stuff like this. We also have, so I was saying the GitHub. So GitHub, you can open issues and we'll try to do our best to answer you as soon as possible. We'll have pull requests also if you want to contribute to these efforts. And we are on the social networks. So basically you can follow up on Twitter, you can ping us. And also we just started a LinkedIn account. So feel free to follow us over there.
Awesome. I know we had a lot of questions that came in that we weren't able to answer. So I just want to say, please, everyone, feel free to reach out to either us at Paperspace. We have our docs at docs.paperspace.com, or, the Hugging Face community is very active and we're pretty involved and would love to kind of see those questions come up. As a reminder, you can, that notebook that Morgan walked us through is available at paperspace.com. Or gradient.paperspace.com. If you have any issues with that, please feel free to reach out, and we will also circulate a promo code for everyone here to actually try out some more powerful GPUs and more pieces of Gradient as well. So thank you so much, everyone. Morgan, thank you. And David, I'll hand it off to you. This recording will be available in a few days here, and please feel free to share, and looking forward to the next one here. Hopefully we'll get some, get the Hugging Face guys back on the webinar. This was super good. Thank you so much, Morgan.
Thank you for having me. Thank you for this great collaboration, and looking forward.
Okay, thank you, Dylan. Thank you, Morgan. Thank you so much for coming on our webinar. We were so pleased to have you. It was excellent. We had so many questions, we couldn't get to everybody, but we encourage you to reach out to us. We have the emails here on the screen for Morgan, Dylan, and myself. Just so you know, we do these webinars every 2 weeks pretty regularly. So we will follow up with a recording of this one, some of the links, the promo code that Dylan referred to. If you're on Paperspace right now, the promo code is HF2020, but of course we'll send that in a follow-up that gives you some credits to try out some of the things that Morgan was talking about, try out some advanced GPUs and that kind of thing. So once again, we'd like to thank you for joining us. We hope you enjoyed it. We'll send you a recording in a day or two after we process. And in the meantime, we hope to see you again at a future Paperspace webinar. So thanks again, and hope everybody has a great rest of their day.